Okay, are you getting my voice? Is it board clear? No, everything is clear. I think a complete board you are getting. Okay, right. I will start actually. We'll 25 students are joined here, so I'm checking that. So I'll start here. I'll complete last class of this Kronig-Penney model. Then I'll cover this Schrödinger time independent particle in a potential box. So I'll tell you the numericals formulas. Just you have to do your numericals. Okay, don't. I'll not go for that all the numericals. Why? Because we have very less time. Tough questions only I will going to cover here. Okay, so everything I will not going to cover. All right. So I'll come to the in front of this camera. I'll adjust the site, and I do not share my screen. Your screen you have to share it. You have to take out screenshot. No, you have to take out your screen. If you are my screen, you are taking screenshot. No, you will get messages. Everything you will get. Okay, voice you are getting. No, yes. One student you have message. Then I will going to continue. Voice you are getting. No, my voice. Yeah, message me. You are getting live session, and voice also you are getting. Yes or no? Just message me. 2 or 3 students your message. Then I am going to come to. I'll come in front of this camera, and I will continue. Once I will start, I will not going to see your messages. Yes sir. Okay, WhatsApp message I got. Yes sir. Okay, right, clear. Okay, now I will cover here. So yesterday somewhat here Kronig-Penney model I am going to cover. So this is your periodicity. Periodicity you have to write down. Periodicity, and this is your plane wave equation. Plane wave equation. For Kronig-Penney model, I said you that in the yesterday. So this is the key point. This is one key point, and Schrödinger time independent is one key point. For region 1, I raised here. Okay, alpha square, where you have in the terms of beta square. No, one more equation we have before that we got. You have taken yesterday. Alpha square psi is equals to 0. That is equation number 1. Okay, so that equation is very important. And this equation third one is very important. So, okay, I am highlighting. You also highlight using the blue and black pens. Do not use red pen and everything and green pen. Okay, you highlight it. Differentiate this equation. So differentiate this equation. So differentiate equation number 3 and substitute in equation number 2 and 1. Okay, I am substituting. I am getting final equation. Final equation I am writing here: p sin alpha a by alpha a, p sin alpha a by alpha a. How I am going to remember? You have also remember this formula: cos alpha a is equals to cos k. Nothing is there here. Sin alpha by alpha a indicating you how the diffraction peak wave you are getting. Similar you have to get here like this. This is the final equation you got. You have to draw. So graph for these final equations. How you have to draw? So you have to take out the graph like this. Okay. So sin alpha by alpha a, you will get the graph like this. Alright. Increasing and peaks are increasing and decreasing like this. You will get sin alpha by alpha a. Okay. So on x-axis what you have to write down? On x-axis is the alpha a you have. On y-axis the complete left side equation. So p sin alpha a by alpha a plus cos alpha a, you have the on y axis. Carefully you have to draw. People are drawing this graph. but properly not indicating what you have to draw on x-axis and what we are drawing on y-axis. Okay, clear? So now, so then how we are going to take out this allowed regions? Means electron will going to pass here, then you will get one allowed region. So cost limits are -1 to +1 only, +1 to -1 only, means you have to get the allowed region is in this region. Okay, both the sides allowed region is in this region, right? Means electron will going to pass and move from the potential barriers like this. Okay, now there is a gap here we have, and once again the allowed region is you have here like this. Allowed region is, this is the one. Okay, every time allowed region is increasing, in the gap this peak will come here downside. Okay, now so gap, how we are getting, some of the electrons are not tunneling from this and are reflected back and move, and there is no allowed region you will get, only gap you will get. Every time the tunneling is increasing, the gap is decreasing, means allowed region is increasing, allowed region is increasing. This will going to increase somewhat height outside, outside the +1 region. Okay, so then allowed region is increasing, then I have to change my graph like this. So somewhat increase like this, and it is moving like this. Okay, somewhat decreasing like this. Right, every side is like this, means allowed region we have to increase and gap we have to decrease, means more is allowing, once it is going to travel like this. So एक होल बना के चले गए ये पूरे इलेक्ट्रॉन्स, तो अपने आप पूरे चले जाते रहते टनलिंग प्रोसेस में, ज़्यादा होते रहते, जितना ज़्यादा हो गए उतना बैंड गैप ज़्यादा होता, सॉरी allowed region ज़्यादा होता, बैंड गैप जो भी कम होते क्या हो रहा, सो इट इज़ टोटली इरेजिंग दैट, व्हाट वन, बैंड गैप इज अलाउडिंग दैट. तो करते 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 क्या हो रहा, पूरा वेरी स्मॉल बैंड गैप यू हैव, देन स्लोली इट इज गोइंग टू एंड दिस थिंग. ओके, अलाउड रीजन ही रहेंगे, पूरे अलाउड रीजन ही रहेंगे, एवरीथिंग इज अलाउड रीजन. सिमिलरली दिस साइड आल्सो यू हैव द ग्राफ. सो दिस इज द इम्पॉर्टेंट ग्राफ फॉर द फाइनल इक्वेशन. फाइनल इक्वेशन के लिए इम्पॉर्टेंट ग्राफ है. ओके, सो आर यू गेटिंग नो? मैसेज मी एस. Why? Because I can't hear this, why? Because I am using here only mic, there is no if your WhatsApp message also not a problem. If you are giving WhatsApp message, I am receiving on the screen, my screen. Someone you do it WhatsApp message. Okay, you are getting, everything is clear, board and my voice is clear. Is it clear? Yeah, is it clear or not, that only you have to message. Yes sir, in WhatsApp. Okay, yes, no. Okay, yes, I think okay, right, clear. Now you are getting a clear thing. Okay, now I will go for the here I will go for Schrödinger time independent wave equation. Chalo, I will going to close out what happened here. P tends to infinity, P tends to 0. I have to close it here somewhat. Okay, when P tends to infinity you will get, so what is happening, so all the lines will going to press, it will look like a one line. When P tends to 0 you will get, okay, so all are allowed regions. This only you have to draw, this is the key points. What you are writing story, that's your choice. These are the key points you will get for the 7 marks Kronig-Penney model. I think most probably you will get tomorrow this 7 marks question Kronig-Penney model. Take out the screenshot. I will continue for Schrödinger time independent and particle in a potential box. Why? Because tomorrow he will ask any one question, definitely one question you will get this this in these 2 questions. Okay, wave mechanics, that is your 3A question, correct or not? 3A question, wave mechanics. Chalo, I'll erase this concept. Clear? So I'll going to erasing this part, and I'm going to start with Schrödinger time independent wave equation. Schrödinger time independent wave equation. Okay, now, so I'll put here Schrödinger, okay, my pen is not working. Schrödinger time independent wave equation, SCHU, Schrödinger time independent equation, wave equation. Independent only you will ask 98%, dependent very rare cases you will going to ask. First you have to prepare, then you go for the similar derivation. You have go for my YouTube channel. I already uploaded time dependent. Okay, similar you have somewhat changes you will get, then you find out that derivation in the time dependent. Why? Because only 2% chance is there to come in your final examination. Most probably Schrödinger time independent only he will asking this in the final examination. Okay, so shall I start this thing? Okay, differential form of wave equation generally classical mechanically how you are writing this thing. Okay, dou square psi by the particle is moving with the time, dou t square, okay, v square del square psi. This is the differential form of wave equation. This is the first equation you have to write down, and you have to remember this thing. Differential form of equation means psi indicating that wave function means regarding wave it is moving with time with velocity v, and you have del you know that according to mathematics del is you have to say dou by dou x plus dou by dou y plus dou by dou z. You know that this thing. Okay, so dou by dou x, dou by dou by dou. I am not writing here about del. So we are going for the del square psi is the first equation you have to write down here. Okay, next I have to take out this equation, solution of this equation 1, solution of equation 1 solution I am writing. Okay, solution of equation I am writing. So psi is equals to, okay, I am writing in terms of psi is equals to psi naught sin omega t, omega you know 2 pi nu. Okay, first I will keep it like this is the solution for the equation 1. So I have to take out, I will keep it in box, and I will keep it is a, this is equation number 2. Okay, so like y is equals to a sin omega t. In intermediate you have studied y is equals to a sin omega t. How it is looked like? Y is a displacement, a is amplitude, omega is a 2 pi nu. You know that omega is equals to 2. I will substitute here only 2 pi nu value. Okay, similar that in terms of y you have the psi, in place of a you have the psi naught and sin omega t. Why? Because you know that about the psi doesn't has any meaning, and you have to use it as a displacement, you have to use it as a amplitude, whatever maybe you have to use it. Okay, clear? Chalo, I will go for differentiate this equation, differentiate equation 2 twice you are doing. First time you are doing, then you will get dou psi dou psi by dou t. With respect to t only you are doing. Okay, but because particle is moving with respect to t, then I am writing that dou psi by dou t. Okay, psi naught is a constant, sin omega t is a differentiation is, okay, differentiation of sin omega t, cos omega t. Sin omega t differentiation is cos omega t, and t before what you have. So I will put it in bracket here like this. In t before omega is there, omega will come this side. Is it clear? This step is clear? S message you, S means I am going to continue, means you are getting this voice and bored. Okay, I think. Hmm. क्या बोलते प्राइवेट से अनलिस्टेड करना है, प्राइवेट में है क्या वीडियो? कुछ 1 मिनट, कुछ सेटिंग देख रहा था, लिस्टेड नहीं मैंने। You are not getting this. You are not getting this video. It is in private. प्राइवेट में है क्या कुछ? गेटिंग और नॉट दिस थिंग? थोड़ा व्हाट्सअप करिए ज़रा, व्हाट्सअप मैसेज मैं देख लेता हूँ। आ रहा नहीं आ रहा? Getting, okay, getting. People are saying getting, okay. Now I have seen one message like you have to unlisted in private, sir. Okay, getting. The students are saying getting. Okay, no problem. Getting you are saying. ओके, yesterday कुछ बोल रहे भाई, इसमें व्हाट्सअप खोला तो ओके राइट। चलो हाँ, चलिए फोकस करेंगे फिर से। One second, you note down. I'll 1 second. I'll going to unmute. Okay. Okay, differentiate this thing with double time. You have to differentiate. Okay. Second time I'm going to differentiate. Then I'll get here dou square psi by dou t square. Dou square psi by dou t square. Then how you are writing psi naught? Okay, psi naught. Omega is a constant once again. So cos omega t differentiation is sin omega t. Sin omega t minus will come, I think, no? Sin omega t. Cos omega t differentiation is sin omega t you will get. Okay. Right, omega sin omega t, and omega also once again you will come here, sin square you will get. I think minus you will get here this. Right. Now you have to see this sin omega square sin omega t. It is look like a this thing, no? This thing. What you have to do? So I will place out. I have to take out different color. Then I have to write down the sin naught. I have to take out sin naught sin omega t value from this equation number 2. I have to write here as a psi. Okay. Now dou square psi by dou t square is equals to minus psi. In place of the sin naught sin omega t value is psi, and omega square will get omega square value. Now I'll put it here. Okay, I'll put it here, omega square value. So omega square value is 2 pi nu. Okay, omega value is 2 pi nu, and square it, you will get it here like this. Then I am writing here dou square psi by dou t square, dou square psi by dou t square is equals to minus of psi. Omega means 2 pi nu. 2 pi nu you will get 2 pi nu whole square. Omega value is 2 pi nu. Okay. So dou square by dou t square from equation number 1. What do you have to write down? V square del square psi is equals to minus psi 2 pi nu means you have to write down like this, no? So square it, then you will get 4 pi square nu square. This is nu square, this is a v square. Do not cancel out both these things, okay? So I have to write down this, I have to cancel out this, then nu is equals to, how you are going to write down? Nu is equals to v by lambda, correct or not? We know that nu is equals to v by lambda. Then I have to convert like this, v square del square psi, so plus minus psi 4 pi square, nu square means v square by lambda square. Okay, then you cancel out that v square and v square, you will cancel out. V square will cancel out. Then what is the remaining you have? You have the remaining is del square psi. Okay, this minus will come this side, plus will get, minus will come this plus. So 4 pi square, I am writing later, you are going to write down. So that psi you have to write down. Psi is equals to 0. Is it correct or not? Check out. So I have, now we will bring it, this thing is this side, plus will get, first I have written 4 pi square lambda square, then I have written psi, this is equal to 0, means in terms of psi you will get answer. Okay, all equations in quantum mechanics in terms of psi will not going to cancel out. Okay, why? Because it doesn't has any meaning while you are studying psi, physical significance of psi. Okay, then you can understand that. So del square psi, what you have to do next step? Then everything is correct. Okay, everything is replaced. These are constant. Why? Because dou psi by dou x, dou by dou by dou x, dou by dou z. So these are a constant. These are also some constants. It means that psi is a constant you consider. The lambda I have to change out. Lambda means de Broglie wavelength. What is the de Broglie wavelength, sir? De Broglie wavelength lambda is equals to h by mv. Correct or not? H by mv. Can I replace with this h by mv? Then I am going to replace with 4 pi square. So lambda means h by mv, de Broglie wavelength. So he will ask one numerical on de Broglie wavelength. Carefully you do it. One numericals on de Broglie wavelength in terms of energy, in terms of potential, in terms of velocity, in terms of momentum. Okay, in terms of temperature. So you have to do it, practice it, numericals on that. Okay. So chalo. So I have to do it here. So del square psi. So I will take out upper side, then I will get 4 pi square. So mv whole square, can I write like this, mv whole square? Okay, then psi, then here downside I am writing h square, so is equals to 0. Clear? It's very clear. This mv I am writing in terms of energy. How you are writing energy? In terms of energy, how you are writing? Can I erase this part? So then I will get some space here. So easy to cover this part, right? Then okay, right. Then I will going to cover this part. So what I have to write down here? So del square psi. Now we know that total energy E is equals to kinetic energy half mv square plus potential energy V. Then I need here mv whole square. I need mv square is there, means both the side we are going to multiply with m, then half mv whole square. Can I write like this? M square v square means mv whole square. Okay, then mv, you have m into v potential, then I will bring this potential this side, me minus mv is equals to half mv whole square, then m is common, e minus v you will get, and here I have to place out 2 also, I will bring this side, 2 mev is equals to mv whole square. Can I put it these values? I have to take out this equation number. Now what is this last one is equation number 2. Can I write it here, equation number 3? This is I consider as equation number 4. Substitute equation number 4 in 3. Substitute it, then you will get final equation. All of you substitute it, you will get final equations. Then you substitute, I am writing here the value of this thing is del square psi plus 4 pi square by h square. So mv whole square means 2 me minus v into psi is equals to psi. Where you have psi? Here we have psi. Psi is equals to 0. Then you have to multiply. Then you will get like this, right? You will get like this, del square psi. So 4 into 2 8 pi square m by h bar square, h square, not h bar square, h square also you have to write down, e minus b into psi is equal to 0. This is the final equation what you got. Schrödinger time independent, there is no dependent of time, so we are writing like this. Okay, that we got final equation here. Then I'll put it inside one. In terms of h bar square you want to write down. Okay, so above equation you take out, the same equation I will take out. So 4 pi square I will bring downside, so del square psi, this is the final equation. Okay, you want to change somewhat a different form, then I am writing here like this, del square psi. Okay, I will write it here, 1 you will get, 1 means 2me, 2m you will get by h square by 4 pi square. Can I write it here, h 4 pi whole square. Okay, 2 pi whole square, h by 2 pi whole square. Can I write like this? I'll bring downside, I'm writing that. We are square take out inside, same thing you will get. Okay, so e minus v into psi is equals to 0. So you know that reduced plus constant h bar is equals to h by 2 pi, h by 2 pi. Can I write like this? This equation can I write it here? Okay, here I am top, I'm writing, just you will get here. Okay, del square psi plus 2m by h bar square, so e minus v into psi is equals to 0. This is the another form of your Schrödinger wave equation, Okay, clear? You got?
Yeah.
S means you have to put it on WhatsApp S. You got, everything is clear? I think above line is you are getting okay, getting or not? Yes, okay, light. Okay, top equation is you have del square psi here, see that. So I have cleared somewhat, then it's clear now. Yeah, yes, getting, everything is clear now. Just you have to practice once, twice, then you will get here like this, these equations. Okay, take out screenshot. I will go for particle in a one-dimensional potential box. Definitely in this one and particle in a one-dimensional box, you will get one you will get on this thing. Okay, chalo. Can I erase it? Take out screenshot. I will erase it. Okay, now particle in a one-dimensional potential box. I will go for particle in a one-dimensional potential box. Particle, not getting this thing. Particle in one-dimensional potential box. Particle in one-dimensional potential box. One-dimensional potential box means application of that Schrödinger wave equation. Potential box. Okay, no, So we will continue that. And Schrödinger wave equation, you know that, then only you will get this equation. Now I will consider that one atom like a one box. Imagine that. Okay, one atom like you have taken one atom. So you atom were like a one box. Okay, potential box. Now at center you have the one nucleus. Okay, leave it this thing. So forget about this thing. One atom like a one potential box. So inside what you have? Electron you have. Electron is moving here. Electron is moving. Correct or not? So somewhat bigger I have to draw here this thing. So now I have to draw one potential box. One potential box. I'll start with x is equals to 0. Length you take out, x is equals to L you take out. Length from here to here, x is equals to L you have to take out. So the potential box height is infinitive. Potential V is equals to infinity we have. Infinity we have. Very high infinity, very high you have the walls height. Okay. Now, so the particle inside is moving, and this is potential will get 0. Why? Because it is trying to jump, but infinity walls you have, then it's once again fall down, the potential will go to 0. Means in this limit the potential is 0 at wall and outside also. At wall and outside also the potential is infinitive. Wall and outside also potential is infinitive. Chalo, we are writing the equation for this electron or particle, we have to say, always not electron, particle. We are writing the equation and we are applying the boundary conditions, and we have to get the energy of that particle. That is the importance of this particle in a one dimensional box. Means inside the electron, inside the atom electron, energy for different energy levels you will get without any computers, mathematical derivations they are given. Now we are using for the quantum computers these energy applications. Okay, just concentrate on that thing. Now I have to write the boundary conditions. Boundary conditions for this, when it is going to happen, x equals to 0, x equals to potential is generally you write down. So v of x equals to 0, you will get here in this region. In this region only we have, and I have to say 0 x L. Means more than 0 means you have to write like this, and less than L you have to write down. At this condition the potential is 0. Potential is 0. When you will get potential is infinitive write down. 0 x L we have to write down. Means less than, the x value is less than 0. Less than 0 means you have to write down. Okay. And at wall also you have that. Wall also you have that. Okay. So x value is okay, it is I think wrong, I think. No, 1 minute. 0 value is x value is more than, no, x value is more than 0. You have to write down like that only. Okay, correct only. L value, x value is less than L. So reverse you have to write down. X value is x value is more than 0. Okay, x value is less than the 0 and outside, and it is L outside. Okay, it is means L is less than and equal also you have the conditions. Okay, now applying this Schrödinger wave equation for this particle in a potential box. So whatever it may be, you are writing here this condition are not a problem, right? Because you are not using this condition in your derivation. Okay, you concentrate on this. Applying this Schrödinger time independent wave equation in one dimensional. Why? Because you have to write down here this Schrödinger. Just now we have written del square psi, correct or not? Del square psi. Can I take out in terms of 8 you have to take out, or 2 pi you have to take out? That's your choice. 2m by h bar square. Can I take out h bar square? If you are writing forgetting the h cross h cut square, the people are saying h cut square, then everything is wrong. So E minus V into psi is equals to 0. E minus V into psi is equals to 0. Now I am moving in the x direction only. That's why I have taken here only x dou square psi by dou x square only you have taken. Means why? Because del means dou by dou x, dou by dou y, dou by dou z. So I have taken only x square position that I am writing here dou psi by dou square psi by dou x square 2m by h bar square. So E minus V into psi is equals to 0. Okay, solution of this wave equation I have to write down in terms how you are going to write down the solution of the wave equation. Okay, solution of the wave equation we have to write down. So here potential for the inside potential is a 0. Can I consider that this value is 0? Dou square psi by dou x square, then 2m by h bar square into E is equals to 0. Why? Because here the potential is 0. Then can I consider this is one constant? It look like a wave equation. Okay, this, okay, here we have psi. I forget to write here psi. Okay, so you will get here psi, no? And this total one I consider as a some constant. So this total one I consider as a some constant. Then it look like a dou square psi by, how it look like? Okay, I will take out here the part how it is look like. I am writing here dou square psi by, okay, I am not getting the inks are proper. Dou square psi by dou x square plus alpha square, some you take out alpha square, psi is equals to 0. This is the differential form of wave equation. Solution of this differential form you have to write down. This is the main point, main you have to take out. Okay, so some people are taking alpha square. If you are going to confuse with what is that with Schrödinger wave equations, sorry, Kronig-Penney model, then I have to take out wave vector k. It's better you have to take out k square. Okay, k square square. What is the k square means? K square means what I have taken here. K square, in place of k square what you have taken? K square is 2m by I think h bar square also will come here. 2m by h cut square. E you have to write down. This is I have to consider as this is some equation number. Okay, equation number 1 you consider here. Equation number 2 you consider. Okay, very clear. So how you got k square value? K square value, this total value is the k square value. 2m by h bar square into E is the k square value. Why? Because if you are discussing about the k, means you are discussing about the energy. These all are constant, no? Okay, k you are discussing means k is nothing but what you say that k value is a I think wave vector we are saying that k is a value. Wave vector we are discussing means energy we are discussing over. Okay, just while you are going to calculations, other derivations, we are going to helpful for to find out the energy value here. This you remember this thing. Okay, then I am going to continue this equation. Solution of this equation 1, how I am going to write out this thing. Okay, so I am writing here solution of equation number 1. Solution of equation number 1. How you are writing solution of equation number 1? So how you are writing in intermediate similar like that. Psi of x is equals to a sin kx plus b cos kx. A, b are constants. Okay, so this is the solution. I have to put it in a box. What is important? You have to write down here this box. I have to write down this is the equation number 3. Clear? Equation number 3 I have written. Then I apply the boundary condition for the equation number 3. Equation number 3 I have to apply the boundary conditions. So here boundary conditions I am applying. What is the boundary conditions? We have to see here that. Okay, if first condition, if first condition I will go for that. Condition number 1. So I am writing condition number 1. If psi is equals to 0, if psi is equals to 0, okay, then I have to place out psi is equals to 0. Why? Because x is equals to 0. Where? Here. Okay, now x is equals to 0. Now I consider x is equals to 0 at this position. Boundary condition means here x is equals to 0. What is the potential value? Potential value is infinitive. See that here x is equals to 0, potential value is infinitive. What is the probability of finding the particle? Probability of finding the particle. Probability we have to indicate with psi or psi square. There is no chance to find out the particle here. Means suppose in prisoner thief you have some thief we have. He's infinity walls we have. He's trying to jump from the wall, but because of this infinity wall, he is not sitting here on the wall or outside. So he will once again fall inside only. Okay, तो अंदर ही गिर जाता है, ऊपर जाता नहीं और बाहर जाता नहीं. Means at x equals to 0 or x equals to L, there is no chance of finding that person. Means there is no chance of finding the that person, means the particle. We are not going to find out the particle. Okay, so chalo. So I'll substitute this boundary condition in these equations. In this equation, above equation, I have substitute these boundary conditions. So in place of psi of x, we already have to write down 0. I have to write down. So a sine k into x plus what you have to write down 0. You have to write down. So b cos k into 0. Okay. So 0 is equals to a sine 0 means 0 only. No, this total one is 0. Correct or not? Sine 0 is 0. Cos 0 is 1, means b you will get, means what you have to get, b is equals to 0 you will get. Clear or not? Then I'll put it in box. This very important. We got b's value is 0. Then I will go for once again. So second condition, second boundary condition. So I will put it second boundary condition. I have to take out second boundary condition. What is second boundary condition? We are going to find out. So then I am going to find out second boundary condition. I said you that at x equals to L, at x equals to L, okay, same color I have to take out. At x equals to L, at x equals to L, what is the potential? Potential is infinity. And what is the probability of finding the particle? Probability, there is no probability of finding the particle. There is no chance to find out the particle. Then applying the above equation, psi of x equals to 0, you have 0, and a sine k into, in place of x, what you have to place out, L you have to place out, plus b cos k into L you have to place out. Okay, chalo. So then what you have to find out here? So this total value, b value is 0 already, fine, above from that. This total value will get 0. Then what is that? A sine kl is equals to 0. Correct or not? Okay, a is not equals to 0. Why? Because a is a constant. How can it is? Suppose a value you have to take out one value. 1 is equals to 0. No, it is not getting that constant is a 0 value. Then you are getting here sin kl is equals to 0. In sine, when you are getting this 0, sin 0 is a sin what is a 0 is a 0. So sin 0 is a 0. Sin kl is sin 0 is a 0. Sin 0 you are getting, sin pi you will get, sin 2 pi you will get. Okay, and so on like that. Means sin kl is equals to sin n pi. Can I write like this, n pi? Can I cancel out sin that our purpose like this? Otherwise you have to write down sin inverse, you take out sin inverse of how much you will get. I will cancel out like this for our purpose. Okay, exact, not mathematics you have. Exact mathematics you have to write down like this. Kl is equals to sin inverse of 0 you have to write down. 0 you have to write down. When you are sin 0, 0, sin inverse and sin will going to cancel out. KL value is you will get n pi. Okay. So I am not going for the exact mathematics. So n pi you will get. What is the n value you have to get from this thing? Or k value you have to get? K is equals to n pi by L. See here. Here also you get from equation 2 k value. So can I take out square? You have to do it. K square is equals to n square pi square by L square. Okay, this is one more equation. So I have to take out. This is equation number 3. I have to write down. Equation number 1, 2, 3 only you have to write down. 4 we have to write down. Already 3 I have taken. Equation number 4. Suppose I am going to substitute first this k value inside this equation. I will get a wave equation. Okay, and equate this k square, then energy equation you will get. Okay, first I will substitute this k value and b value. Why? Because a value, a is not equals to 0. I will put it, a is same like that. B value I put it 0 and k value I have to put out n pi by L. Then I am getting final equation is like this. Psi of x is equals to psi of x equals to a. I am writing same. Why? Because I said you that here a is not equal to 0. Sine okay, k value is n pi by l. K value is n pi by l into x. This is the wave equation for the particle. Means this particle wave equation is this. We got wave equation. Suppose he will ask derive the expression for wave equation inside the one dimensional potential box, means you have to end up to this point. Suppose he is asking the derive the expression for the energy of the particle, means you have to equate equation number 2, equate okay, equation number 2 and 4, equate 2 and 4, then you will get energy equation. Then I am going to equating this right side of this equation, 2m by h bar square into E is equals to right side of this equation n square pi square by l square. Okay, now E you keep it and remaining you take out that side. E is equals to n square okay, pi square by l square, so then into h bar square by 2m. If you are going to expand this h bar, then cancel out some things. Okay, what is the h bar term? H bar is equals to h by 2 pi, you know that, reduced Planck's constant. I'll substitute here h bar square value here, then we will going to cancel out n square pi square l square into h bar square means h square by 2 into 2, 4 you will get, no, 4 pi square m, 4 pi square m we have to take out, right? Please think. Okay, I am thinking something I am missing. Yeah, here one more 2 you have. So why? Because it is going to square, you will get here directly. I can write it here 8 I am going to write it here, then pi square get cancelled out. Okay, then remaining what you have to write down, remaining I am writing here in this equation. Can I use this part? Okay, I'll use this part. Inside I am writing this equation. Very good. No, looking good. Okay, now what is the energy equation? Energy equation E is equals to n square h square by 8 okay, m l square. This is the final equation. This is the final equation where in this particle has energy. N is equals to 1 2 3 4 5 and 6, and similarly you have to take out different values, right? Clear? Then you have to take out n is equals to 1, draw the diagram for the potential box. What is the energy and wave diagrams you have to draw. First you take out screenshot this thing. I will going to arrange by using this. I have to draw here the boxes. Take out screenshot, all of you. Yeah, you are getting or not? Just you message me and WhatsApp. S means I will going to continue. Okay, I will not take much more time for yours. You are getting? So message on WhatsApp, yes or no? Okay, yes I received. Okay, nice. Just you take out screenshot. I will going to erase this part. Okay, this right side part, this part I will going to arrange and I draw this for this equation. I am drawing here some diagrams. Okay, now I will erase this part. So I am drawing here the equation for this thing. Okay, I will erasing this part. Then okay, then I have to take out these things. Okay, if n is equals to 1 I have to place out, E is equals to E1 I am placing, just E suffix n you have to place out. Suppose n is equals to 1, then 1 square means h square 8 m l square you will get it. Okay, then E is equals to 2 I have to place as 2 to the 4 h square 8 ml square. Can I write it here 4 E1? 4, this part is E1 value, this part is E1 only, no? Then E is equals to 3, then 9h square. See that it is a quantized. Okay, energy levels are quantized, not so it is extending like this. It is not getting, see that after one E1 you are getting, no, directly not 2E1, 3E1, you will get 4E1. Next 5, 6, 7 you will not get, 8 you will not get, directly 9E1 you will get. Means it is a quantized, that it is not continuous, you will get here, it is a discrete form. From this concept, the conclusion is the energy levels are discrete. The energy levels are discrete. So can I draw like this? Your if E is equals to 1, sorry, n is equals to 1, n is equals to 1, what is the value is E1. Okay, then E is n is equals to 2, then what is the energy level? So what is that? 4E1, 4E1. So n is equals to 3, what you will get? 9E1. Okay, it is jumping electron like this, not 2E1, 3E1, 4, you are getting 4E1 jumping plus 5E1, 6E1, 7E1 jumping. Not. Now we are writing the wave equation. What is the wave equation we have written just before? Psi of x is equals to a sine 2 pi by L, k value is 2 pi by L into x. Can I take out suffix n? Then how you are writing? Okay, fall down. Okay, psi of n is equals to, psi of 1 is equals to, okay, psi of 1 into x is equals to a sine, so 2 pi, I think n you have, I think, n you have, 2n pi is there, no? I forget. I think 1 you will get here, by 2n pi L into x. If psi 2 you take out, psi of 2 you will get, I think a sine, okay, n pi by L, no? K square is equals to n pi by L you will get. I think I forget here. Okay, 2 to the 4, I think 4 pi by L you will get here. Okay, now so I will get n is equals to 1, then 1 loop you will get, 1 loop you will get, n is equals to, acha, here psi of x, n is equals to 1, no? 1 you are taking, not square here, n is equals to 1, 2 pi by L, n is equals to 2 into 2, 4 pi by L you will get, 4 you will get, 1, 2, 3, n pi by L, no? N pi by L, pi by Lx, 2 pi by Lx, 3 pi by Lx, like this. So n is equals to 1, 1 wave you will get like this. N is equals to 2, 2 waves you will get like this. N is equals to 3, 3 waves you will get like this. Okay, 1, 2, 3 waves you will get. I think 3 waves, n pi by L, I think. Formula is n pi by L. Okay. So here not 2 pi by L, n pi by L you will get, I think. N pi by L. Okay. So then, so you will get here like this psi value. If you are writing psi square means this is also you will get in positive value. No need to draw. For our sake, you need must good marks you will get. You have to draw this psi square graph also. Means both you will get in one side only. So this all the graphs you will get in one side only. Okay. See this. This is your psi square values, no? N is equals to, this is psi graph. This is psi of x graph. Okay, psi of 1 graph, psi of 2x graph, psi of 3x graph. This is psi square. So, okay, psi 1x square graph, psi 2x square graph, psi 3x square graph. N is equals to 1, same like that, E1. N is equals to 2, what you read in 4E1. N is equals to 3, 9E1. Okay, clear? This is clear? Up to this point is clear? Yes, no? Yeah. Take a screenshot and I will write some chapters name and formulas name where you are getting the numericals. Okay, I'll have you take out screenshot. I will write it here. So formulas and everything I have to take out here. Okay, I will erase this thing. Right, clear? I will erase this thing. So in which chapter he is asking? The students, some in WhatsApp group, in WhatsApp regularly the students are asking. I told you last yesterday, don't study. Somebody is giving some are important questions. Don't study like that. I said you that you are studying the questions like a question wise. You have to study 2a, 2a. These are that. Okay. 2b. What you are asking? That are these. 3a. You have just now I said you that Schrödinger. Kronig-Penney model he will going to ask. B part maybe he will going to ask semiconductors. Kronig-Penney model semiconductors. For A he will going to ask Schrödinger time independent particle in the potential box. Question wise you have to study. Don't go for some questions you are taking, sir. I am going to pass out if you are going to study these questions. It is not like that. If you study any three questions now perfectly, A B A B A B you are studying, then you are going to pass. Otherwise you are not going to pass. So I given you top 15 questions in the short questions also I given that you have to follow it. Okay, clear this concept. So I will wait for 2 minutes. Aza is going on. Just I will wait 2 minutes. Then I'll continue on what topics, what formulas he'll going to ask the numericals. Maybe he'll going to ask numerical this time. Okay. So chalo. Wait for 5 minutes. Only 5 minutes. Okay, we will continue this thing. Aza is over. Then I will going to continue some which formulas you will going to ask the numericals. Okay. So I will conclude these things this class. So first chapter. Okay. So what is asking? 2d sin theta equals to n lambda. What is the formula here? Product's law. 2d sin theta equals to n lambda. Generally you are studying from the school level, and he is asking on this numericals on 2d sin theta equals to n lambda. Okay, next. Second question, he will ask d formula, d derivation, d is equals to a by under root of h square plus k square plus l square. So in crystallography only we have d is the interplanar distance, interatomic. Don't confuse with interplanar and interatomic. A is the interatomic, interplanar, Miller indices, HKL values. Okay. Third numerical he will going to ask. A defect he will not ask. Okay. Now I'll come to the downside. Kronig-Penney model you don't have. Sometimes in the semiconductors he will going to ask. Okay, in Ni formula he will going to ask some constants into e power eh nu by kVt. Very rare cases he will going to ask. You will find out these numericals from the internet. Okay, or Kareemsir notes you will going to find out. Kareemsir PDF you will going to find out this. Very rare cases he will ask about the third one, Ni formula. Okay, some constant into e power some I forget this constant. Okay, e power something is there, e power h nu by kBt something is there, h nu by kBt something is there. Okay, So on this formula he will going to ask Ni formula. Ni formula you have. Next fourth numerical he will ask from the what is the Hall voltage? Hall voltage VH formula. Hall voltage VH formula. Okay, Hall voltage you have to find out. First RH you have to find out and then substitute in this Hall voltage formula. Okay. Next fifth question he will going to ask de Broglie wavelength lambda. De Broglie wavelength lambda is equals to h by mv or in terms of h by under root 2 me or under root of h by under root of what is that potential under root of some 12.27 into like you find out all the types of in terms of temperature. I said you that. Next you have to find out sixth question, sixth part you have to write down numericals on what is that downside I will come to that energy equation. Okay, energy equation E is equal, just now we proved no, n square h square by 8 ml square, 8 ml square. You have to take out m value is a mass is constant, mass value is for the electron 9.1 into 10 power of 31 and h value is a Planck's constant 6.625 into 10 power of minus 34. So you have to write down and L value will give, you have to find out these things. Okay, seventh one you find out downside I will come. What you have chapter dielectrics. In dielectrics you will not ask any numerical. Magnetic material in superconductivity you will ask maybe, but it is not important. In Karim sir notes you have to write down. So 1 or 2 numericals you have superconductivity. So on HC critical field we are finding that. So no need this thing, I think no need this thing, but because not regularly asking, not he asking from this numericals only he will ask. Next very important one is the laser and optical fiber. In optical fiber, so what is that? Eighth one is optical fiber. Here I am writing here. So numerical aperture formula. Okay, numerical aperture is equals to under root of n1 square minus n2 square by n1 naught. Regularly he is asking very easy numerical equation and Hall voltage and a de Broglie wavelength and a numerical aperture. Okay, and energy. So these are very important, very important formulas. I am going to here tick. This is second equation, this is Hall voltage equation, this is a de Broglie wavelength, this is the energy, and this is the numerical aperture. These are the formulas you have to remember. He is asking regularly this on these formulas. So try to complete this in this at home, and you find out. I said you that you practice this. Who are writing is very bad, no? You go for Schrödinger time independent and particle in a one-dimensional potential box. Similarly, in Maxwell equations, differential form to integral form. You practice it. Who are writing is very bad. And there is pointing vector. Maxwell's differential form to integral form. And the second part is pointing vector is no. Pointing vector is there. Okay. You practice these two. Definitely one question he will going to ask from the Schrödinger. Maxwell differential form to integral form. Integral form to differential form. So one and he will going to ask from the pointing vector. So in these two he will going to ask that one. And last unit you know that from ruby, helium neon and semiconductor laser, definitely he will going to ask one and practice it. And construction working diagrams are very important. So I am not going to cover in this video all these things. Why? Because you have very less time, you are in the tension, what we have to prepare, what we have not prepared. So I said you that question wise you have to prepare any 3 questions from the starting 3 or starting 1 you have to prepare. First unit compulsory you have to prepare everyone. Why? Because last choice question, 6th question he will going to ask maybe from first unit. Every time he is asking from the first unit. That's why first unit means crystallography and crystal defects you have to prepare it compulsory. Then remaining 4 units you have no. In that you have to study from any 2 units you have to prepare, 3 units questions you have to prepare. Then definitely 100% inshallah you are going to pass out inside the examination. It's not very difficult. Okay, so you have the derivations in my YouTube channel you have, and go for that. What you need carefully once twice you have to listen and practice it, and tomorrow you will get good marks. Okay, I am hoping that you are getting good marks inshallah. Okay, thank you, and best of luck for your future. Okay.
बाबा 5 बजे